Okay, I am going to record Chapter 9, Problems. These are the problems that you'll find in the lecture PowerPoint slides. I will start with slide 7, and there's actually two different slides that have questions. I will read them aloud, but when you do this, you'll have them hopefully printed out, and then you can follow along with the video as well. The first problem says how much heat in joules must be added to a 75-gram iron block with a specific heat of 0.449 joules per gram degrees Celsius to increase its temperature from 25 degrees Celsius to its melting temperature of 1535 degrees Celsius. Okay, so what do I know? I am given the mass of the iron block, so I write those out. Mass of iron is 75 grams. Then I'm given the specific heat of iron, so little c for iron is 0.449 joules per gram per degree Celsius. I'm also told that I raise the temperature, or I'm supposed to raise the temperature of this block of iron from 25 degrees all the way to 1,535 degrees. So my initial temperature is 25 degrees. That's where I start. And I'm raising the temperature to a final temperature of 1535 degrees Celsius. I am then asked to find how much heat in joules am I required to perform, how much heat I'm required to put into the system to raise the temperature from 25 to 1535. Okay, we know that Q, we know the formula for it. Q is given as the mass of the metal of iron times the specific heat for iron times delta T. Delta is just a change, so delta T means the change in temperature, which if I expanded it would be final temperature minus initial temperature. You'll see this as T2 minus T1. Either way it's the same, but it's still multiplied, so I'll write it again over here. Mass of iron times C for iron times T final minus T initial. For this problem then, we have everything because we have the mass of iron, we have the specific heat for iron, we have the final temperature, and we have the initial temperature. So I have all of these variables here. The only one that I don't have is Q, and that's what I'm finding out. So let's plug in the numbers. Mass of iron is 75 grams. Go ahead and write the units because they will help you. Multiplied by the specific heat, which is 0.449 joules over grams times degrees Celsius. Multiplied by 15, so this is multiplied, 1535 minus 25 degrees Celsius. My degrees Celsius will cancel, my grams will cancel, leaving me with joules, which is the unit I want. Heat is measured, or energy as well, is measured in joules. Now, if I do this math over here, this will be 10. So 1510 degrees Celsius, that will cancel out. And now if I do all this math, I get 50,849.3 joules. If I want to convert this to kilojoules, I divide by 1,000. So 1 kilojoules over 1,000 joules, because 1 kilojoule has 1,000 joules. My joules cancel out, and I have 50.85 kilojoules. That's how much energy I need to add to this system to get the temperature from 25 degrees to 1535. Let's look at the next problem in this slide. Okay, the next problem in that same slide is a piece of unknown substance weighs 44.7 grams. So that's my mass. 44.7 grams. And it requires 2,110 joules. So anytime you see joules, that's a measure or a unit of energy. So that's my Q. Q is equal to 2,110 joules. To increase its temperature from 23.2, so that's my initial temperature, 23.2 degrees Celsius, to final temperature of 89.6 degrees Celsius. What is the specific heat of the substance? I need to find the little c. What is C? Just a slightly different problem, but once again, I'll have 4 out of 5 unknowns, and so I can just solve for the last variable. What do we know? We know that Q is equal to M, so the mass, times the specific heat, times delta T. How do I isolate C? I divide both sides by the mass and delta T. Mass, delta T. My mass cancels here, delta T, delta T. So I have Q divided by the mass and delta T equals my specific heat, C. Now I can go in and I can plug what I know. So C is equal to Q, which is 2,110 joules. Use the units. They help. The mass is equal to 44.7 grams times final temperature minus initial temperature, 89.6 minus 23.2, and that's in degrees Celsius. Okay. Now, if I do this, I'm just going to give you this. If I do that, I get 66. I got blacked out here for a second. 66.4. No. Yep. 0.4 degrees Celsius. Okay? So all I have to do is take the amount of heat, so 2,110 joules divided by the mass, 44.7 grams, divided by 66.4 degrees. If it's hard for you to do it that way, multiply these two bottom numbers first, then you take 2,110 divided by that product. If you want to do it in one step, you can take 2,110 divided by the mass divided by 66.4. And that should give you a 0.711 joules per gram degrees Celsius. In general, the specific heats are going to be small numbers. They're going to be less than 1 typically. Water is the exception where it has a huge specific heat. Most values are going to be lower than 1, especially of the metals that we're going to deal with. So if you got a number here that was really large, then you've done something wrong. For example, if you took 2110 and divided by 44.7 and then multiplied by 66, you'd get a huge number here. So make sure that you do the math correctly, and if you get a number that is a large number, then for specific heat, then you will know that, oh, I've done something wrong, I need to check my math. Note the units as well. So I have joules per grams per degree Celsius, which are the correct units for C. That's problem number 2. Now I'm going to erase this and we'll do problem number 3. Now for the third problem, how much would the temperature of 275 grams of water increase if 36.5 kilojoules of heat were added to it? What do I know? I see kilojoules. That tells me that that's a unit of energy, which means that's my Q. Q is equal to 36.5 kilojoules. What else do I know? I know the mass of water, 275 grams. And what am I asked to find? How much would the temperature increase? So it's asking me to find delta T. Then I will actually add one more step to this. I haven't done it here, but I'll add it to the PowerPoint, and I will do it here. So let's find delta T, which is the original problem, but I want to show you one more step. So what was the initial temperature of water if the final temperature was, oh, I don't know, 85 degrees Celsius. We'll just do that. What was the initial temperature of this water? So we'll find the initial temperature as well as the delta T. Okay, what am I missing here? I am missing, so I have Q, I have the mass. I'm looking for delta T. I'm missing the specific heat. Now the specific heat for water is pretty well known. So it's used commonly. So I know that C for water is given as 4.184 joules per gram degrees Celsius. That's the specific heat for water. Now I have all the pieces and I can figure out delta T. Before I do that, I will convert the heat from kilojoules back to joules, because I know that Q equals MC delta T. For that, my units are going to be in joules, because here's the specific heat is joules per gram degree Celsius, so that this has to be in joules as well. Okay, how do I do that? I know that 1 kilojoule has 1,000 joules. I want to get rid of my kilojoules, so that will go on the bottom. Kilojoules, 1 kilojoule has 1,000 joules. So my kilojoules cancel, and I multiply, so 36,500 joules. Once again, if you're going from a larger unit to a smaller unit, you multiply, so that will be a larger number. If you're going from a smaller unit like joules back to a kilojoules, which is a larger unit, you divide so that number is smaller. See the difference here? So if you're going from a larger unit, the kilojoules, to the smaller unit, you multiply by the conversion factor to get you, typically these numbers are larger than what you start with. Now that I have done that, I can go ahead and write my formula. Q is equal to MC delta T. These are multiplied. I want to find delta T. So delta T, I divide both sides by MC. MC. Mass cancels, C cancels. I'm left with delta T over here. Q over MC, now I have everything that I need. I can plug the numbers in, so 36,500 500 joules divided by the mass, which is 275 grams, divided by 4.184 joules per gram degrees Celsius. My joules will cancel, my grams will cancel. This is 1 over 1 degree Celsius, which flips the degree Celsius up on top. Okay, and delta T is going to be equal to 31.72 degrees Celsius. So I found this one. Now I want to find the initial temperature. How do I do that? Well, I know the final temperature. I know what delta T is. I can find the initial temperature. So here it is. I know that, well, I can do it this way. Delta T is equal to T final minus T initial. So to isolate T initial, I add, T initial is going to be equal to the T final minus delta T. I just did it in one step. So minus delta T. T initial then is going to be final temperature, which is 85 degrees Celsius, minus delta T, which we just calculated up here, 31.72 degrees Celsius. And I don't have a calculator, but you can figure that out. Well, let's see. We'll do it over here. 85 minus 31.72. So 53.28 degrees Celsius. That is the initial temperature if the final temperature of that system is 85 degrees. Okay, that's the end of the problems for that one slide. I will make another video for the problems in the next slide.